Here comes the, y'all don't really want it like that. Yeah. Here comes the, no. Here comes the, here comes the, y'all don't really want it like that. Yeah. Here comes the, no. Here comes the, here comes the, y'all don't really want it like that. E-double-L. I said so. I keep big bills up in my hood on the dirty like blood, so ain't got no.
Avenue, and then we'll take it higher. Oh, we're gonna rock down to Electric Avenue, and then we'll take it higher. Working so hard like a soldier, can't afford a thing on TV. Deep in my heart I abhor ya. Can't get food for the kid. Good God, we're gonna rock Electric Avenue, and then we'll take it higher. Oh, we're gonna rock down to Electric Avenue, and then we'll take it higher.
So, Chris, we got this physics project we got to do by the end of this week. I mean, that's ridiculous, right? Yeah, it is. I didn't really think about it. I don't know what we're gonna do. I don't know. I don't even understand all of what we're doing. Like, speed of waves. What is that?
Well, you see, Jason, speed of waves. There are 3 ways to find speed of waves. The first equation to find the speed of a wave is speed equals distance over time, or velocity equals d over t. So, you're going to need a ripple tank for this, because it's most likely the easiest way to do it. So, you have a ruler on the bottom, maybe 30 through 40 centimeters, doesn't really matter, measure that out, and then the waves will come up as little lines. So, follow with your finger like this, time how long it takes to go that 30 or 40 centimeters, that's the time, and then same thing with the distance, how far it goes during that time. Now, you just gotta remember, speed equals distance over time. So, do you get it now?
Yeah, sure. So, what's number 2?
Well, number 2, you're still going to need a ripple tank, and you can use the equation speed equals frequency times wavelength, or V equals F times the cool symbol. To get the frequency and wavelength, you have to use a strobe disc, which is, you just spin it around on your finger like this. And then, for frequency, you have to find out how many slits were in that disc that you're spinning around on your finger, and divide it by the time of rotation of the strobe disc. For wavelength, you can find that by using the strobe disc and a ruler underneath the ripple tank, like for this equation. By using the strobe disc, the waves will look like they're standing still, and you can see how long the spaces between the crest and the trough is.
Yeah. Just fine, Frosty. So, Chris, when are you going to tell me about number 3? Seriously, Chris.
So, Jason, number 3, video analysis. Now, with the video analysis, we videotape the waves underneath the ripple tank, and we plug that into Logger Pro, and you have to put in a certain measurement so that the computer knows, you know, like how the distance is. But you get this graph right here, and this graph represents D, which is the Y value, and t time, which is the x value. So d over t equals velocity, which is the graph. So yeah. So Jason, do you understand this yet?
Yeah, sure. Just don't really understand why you need to put that on my ceiling.
Yeah, I don't know. Okay. So, we both know that I know how to calculate the speed of a wave. But I have no idea what reflection is. Do you have any idea what reflection is, Jason?
Yeah, Chris, I guess I can help you out. So Chris, if you look here, you can see reflection is when a wave bounces off the barrier, and all three, the frequency, the velocity, and the wavelength all remain the same. Also, the angle of the wave when it hits the barrier, the angle will stay the same when it bounces off the barrier. Okay, so this diagram shows that the wave coming in will bounce off at this angle. And when it bounces off, it will come off at the exact same angle. Okay, so this is our example. Now these two hockey sticks are the exact same length. So we'll have our mirror as our barrier, and I'll hold my laser pointer at the same height as the blue hockey stick. So if we hold it here, and I hold it at the right angle, exactly 45 degrees, it will end up at the exact same length as the red hockey stick, showing that the angle is the same for both of these.